Good afternoon, everyone. Welcome back. Today, we are going to start on the topic of statistics. So, up till now, you have done the mathematics portion, then you have finished with the logical reasoning, and now to the final part, that is the statistical part of your syllabus of mathematics. Yes? Okay. Yes, Srinidhi, Lakshita, Bihu, Rohini, Samina, Soumya, and Chanchal. Yes, welcome and good afternoon. Okay, so let us dive into the first chapter. The first chapter is talking about statistical description of data. Now, for this, we would like to first understand what statistics is, how it is useful to us, and how we can use data that we are collecting, or rather, how to collect the data, then how to present the data, and then how to use the data. That is all is covered under statistics. So today we're going to talk about what is statistics and how to collect the data, and simply understanding what data is. And then later on, me and other faculties will talk about how to use this data and get information from the collected data. Okay, so now, like when we are talking about rainfall in India, so you have in your 10th standard, up to 10th standard, you have seen this chart of India, and then mapping of where the rainfall is, how good or bad it is. So we have studied that. Then those of you who are very good fans of cricket, so you can see in the second chart we are showing how Kohli is doing, how his running, how his batting is there, and at the same age how Sachin was doing. Okay, so in this chart, in the second chart, we are trying to compare the performance in cricket of Virat Kohli with Sachin Tendulkar. Okay, so that will also show up very interesting information when we are trying to understand who is a better player, or what type of how their playing strategies are different. Okay, then the third chart we are showing, in the third chart we are showing information about elections in the US. So this in this we are comparing the elections in which Obama was there, and in which Bill Clinton had, not Bill Clinton, Hillary Clinton had taken part. So here we are comparing the four candidates, that is Obama, Clinton, Romney, and Trump. So how their performance was, and how it impacted the political situation in the US. Okay, so these are the various ways in which on day-to-day basis we are interacting with statistics without even knowing it. So when you're listening to the commentary for cricket, you are hearing all these statistics. So there in commentary also you will find that separate people are sitting who are analyzing whatever information is being happening, is a live information, and then they are simulating it, and then the commentator tells you about it. Okay, so statistics, the word statistics can be used in two ways, in the singular way as well as in the plural way. When we are talking of statistics in a singular way, we are talking about the scientific methods of dealing with data. Okay, so what is that? That is, we are talking about collection, then analyzing, and then presenting the data from which we can draw the inferences. That is when we are talking about statistics in the singular form. So it is also called a science of counting or science of averages. Okay, when we are talking about the plural sense of statistics, which we are actually using, it refers to the actual data that is collected and analysis. So singular is talking about the methods of doing it, but in plural we're talking about the actual data that is collected and that we are going to analyze. Always remember that data can be qualitative as well as quantitative. Whenever we talk of data, and we are also everywhere you're talking about data analysis, how to be a data scientist, etc. So all these people are using statistics in one way or the other. And so when we are talking of that, we are not only talking about countable things like weight of a person or height of a person, but we are also talking about the qualitative aspects, or the or what we are known as attributes of the person. Okay. So we have to understand both this, and we are going to do that. So like in statistics, we were talking about Tendulkar versus Kohli in the early example, or we can even talk about, if you are fans of tennis, you can see right now the US Open is going on. So how Nadal is performing, how Alcaraz is performing, all those things are included in statistics. So just now the match ended, and so it was a very long drawn match, 5 hours match. So immediately the commentator is talking about which were the longest matches up till now in the US Open. Then he compared it with longest matches around the globe, So all this information you can get using the statistics tool. Now we are going to discuss about how statistics is applicable to our everyday life. So first we are talking about how it is applicable to economics. So it is one of the most important aspects of econometrics. So then economics and statistics are very closely related. So when you were studying economics, you are talking about GDP and national budgets, and all those things are requiring you to deal with statistics. Okay, so we have time series analysis, index numbers, etc. Then it is also useful. Statistics is also useful for business management. So what earlier used to happen was, when data was not so easily available, or like I have data about my business, okay, but industry standards, or how the industry is performing vis-a-vis my company, vis-a-vis the industry. Like suppose I'm a TV manufacturer, how are the other TV manufacturers performing? So all the data is now collected by the union, and then it is published by the union or the government, or the industry segment, not even union, the industry segment. So the industry associations will collect this information and make it available. So that information is now available. So otherwise, earlier, there was a lot of reliability on hunches or my experience only. But now, using this experience and using the data that is available, I am able to make more informed judgments. Okay. So like whether or not to go in for a merger, or whether or not to go in for an acquisition, should I change the salary structure of my company? All those information or decisions can be taken on the basis of data that has been collected. Okay. Now, one of the latest example is, you see that McDonald's earlier in the cities, you usually had one McDonald's per city. But now you can see even the B towns, that is the smaller towns, also are having more than one McDonald's. So how does McDonald's decide when and where to open a new outlet? So it is going to be taking into account information like residents' average income, whether or not they will be able to afford it. Then what is the spending capacity? What is the traffic density? Okay, all those information is gathered, and then McDonald's makes a decision to open a branch or a new store over there. Then in commerce and industry, what is the application of statistics? Same thing, it is broadening into making decisions. Okay, so what can be the tax structure, what tax is okay for that industry segment, all those things are decided. And like when we are talking about financial stability, so finance, so we are talking about cash flows. So all this is information that is put it in a statistical form. Okay. But all this is very good, but there are certain limitations also when I'm talking about statistics. So first limitation is statistics deals with aggregates. So it is not considering individual as a person, but it considers individual as part of its sample size, part of its data. Okay, so suppose I'm considering the salary of one area of say United States, and then I just include the information of suppose Bill Gates' house or Bill Gates' salary. So what is going to happen? The whole information is going to change tremendously. So that is why it is so important that I consider this aspect differently. But because statistics deals with aggregates, the individual data is treated insignificantly. Then statistics considers quantitative factors only. Suppose in my company, I want to employ postgraduates only. Okay. So I'm thinking only about that criteria, and I'm thinking about when I'm searching to people about that. So what happens is, what is important, what is the other important aspects we are not considering, like the qualitative characters like honesty, passion for doing work. So all this is not considered. Okay, so these things are missed out. So socio-psychological factors are missed out when we are dealing with statistics. But you know, now more and more social, then ECG, environmental, social, gender, those data is also being collected, and those have also are being also processed. Okay. The third disadvantage is that statistical projections are based on set factors and under specific conditions. So when I'm doing that, then although I think that during the course of my my project or my gathering of information, all the other factors are remaining same or stable. But like for example, I'm considering right now it's a rainy season, I'm considering the collecting information about rainfall in a particular region. Okay. So when I'm collecting that rainfall, suppose I'm collecting information about rainfall in Rishikesh. So at that time, I'm just collecting the information. But what happens if there is a cloud burst over there? So those are an exceptional event that is happening. You don't have a cloud burst every day, right? So that exceptional event is not projected, or that is going to affect my whole average rainfall data. So that separation should also be considered, which in the overall picture is not considered. But now things we are able to like put it in the footnote, or we are showing that information with this information, data with this information of cloudburst and without the cloudburst. So we are even giving information in comparable form. But overall, statistics is not considering those factors, or it is considering that things are remaining the same as and when I'm considering I'm collecting the data. Okay. Then statistical inference theory is based upon random sampling. Okay. So when I'm taking a sample, sampling is a very important aspect of getting good results or good information, or to be able to draw relevant and fair information, fair deductions from the data will happen only when your sampling is correct. Okay, the method of sampling is good, or when not correct is good, and it has the sample size is big. Okay, like when the elections happened for Hillary Clinton, what happened was that the information, that the sampling was collected from most of the Democratic voters' families, and so it was giving that she had a chance of winning. Her winning chances were 92%. But what happened was, more Republican families also, if they had collected information, then the projections would have been different. Okay, so it is imperative that the sampling be done properly. So just a quick recap: statistics deals with aggregates. Statistics is concerned with quantitative, and the theory of statistical inference is built upon random sampling. So if the rules of random sampling are not strictly followed, then the conclusion drawn may be biased conclusions. So this is about what statistics was, and now let us go to collection of data. Yes, good afternoon. Lakshita, hunches means what? Hunches means मेरे मन की बात, मेरी मन की आत्मा क्या बता रही है मुझे. So that is. So what I feel, what is coming to me, those are hunches. Okay, collection of data introduction. So what is data? Okay, we are everywhere. We are listening about data and how India is becoming a hub of data. So, or data analysis. Indians are very good at data analysis, being data scientists. So, what does it mean? Data is quantitative information. Okay, so it is quantitative information about a particular characteristic that is under consideration. Okay, means what? For example, I am talking about heights of students in a class. So what data will I collect? What is the information that I will collect? I will collect information about height of each student in my class. Okay. So what is the particular characteristic? Height. And what am I considering? My class, and in my class I'm trying to take values of the height of each student. Okay. So when I'm considering the qualitative factors, these need to be converted into quantitative factors. Okay. So later on, when we'll be doing about regression and correlation, there you will be able to see that when I'm talking, I want to make calculations about a beauty contest. So how do the judges judge in a beauty contest? So in that case, what happens is this beauty, which is an attribute, is converted into data into quantitative, and then we are collecting information. So judge 1, judge 2, judge 3, they will give the marks, and then that information is analyzed. Okay, so qualitative characteristics are to be converted into quantitative, and then they will be used for analysis. So there are two words, variable and attribute. So what is a variable? Okay, what is a variable? Variable is something that can be counted. Okay, measurable. Okay, counted, or is a measurable quantity. Then this variable may be discrete and may be continuous. Okay. So discrete is, suppose I'm talking about number of people, so then it will be discrete, or number of flowers in a petal, that will be discrete. And what is continuous is when the information is going to lie within a range. Okay, so when I'm talking about height, so it can be 154.53, or it can be 154.44. So those type of things are continuous. Okay, so where the data is given in a range. Then the qualitatives are called as attributes. So when I'm talking about attributes, these are qualitative. Like nationality of the person or color of the eye. So we are talking about attributes. Yeah, attributes are generally not comparable. Generally not comparable. So for example, I cannot say this rose, comparing this rose with another rose, okay, in terms of just the color. Suppose I have 2 red roses, more red, more less red. Okay, so that comparison becomes like it becomes very subjective. So I may have a different view and you may have a different view. So that is why we say these are not logical statements. So we will usually talk about qualitative data in terms of attributes. Okay. Now, how to collect the data? So first we talked about what is statistics. Then we have talked about what is data. Data can be qualitative or quantitative. Qualitative, we talk in terms of attributes. Quantitative, we talk in terms of discrete and continuous. Okay. Then we are now going to talk about how to collect the data. Okay. So data can be primary data or secondary data. Okay. Data can be primary and secondary. Data which is collected first hand, okay, by the analyzer is called as primary data. Okay, so your PT teacher in the school, he will ask you to stand in a line, and then for each student he will call, he will take your weight, he will take your height. That is known as primary collection of data. Okay. Then what is secondary? In secondary, the information is already collected by some agency, and that is now we are going to use that data. Usually international international organizations or domestic government organizations, they will collect data, and that data can be accessed by anyone, or some of them may be paid information that you can access. Like when we are talking about malnutrition among children, so government data is available, like in which areas of India you find the malnutrition children, kuposhit balak kahan pe honge. So that information is available. So using that information, like suppose my trust is there who would like to work for betterment of children. So I'll be able to identify the areas, suppose in the which is nearest to me, and I would like to go and work over there. So that information is called as secondary data. Okay, so primary data is when the analyzer, the person who's going to analyze, collects the information himself or herself. But secondary data is information that is available and that I'm going to use. How to collect? Okay, so when here I'm talking about collection of primary data, so I need to understand how I can collect that data. So there are 4 methods. Now, first is the interview method. Okay, so I go and talk to the person, but in this interview method also there are 3 different ways in which you can hold an interview. First is the personal interview, second is the indirect interview, and third is the telephonic interview. Especially in these COVID times, you are having more and more telephonic interviews for placements also, telephonic means even the Zoom calls and all those will come under that type of interview. Now, what happens in the personal interview? In this, there is a physical meet. Okay, people are physically meeting. The investigator will meet the respondent, means the other person directly, and covers information. This is usually used in natural calamity like cyclone, pandemic, for quick and accurate collection. The disadvantage for this is that it is very difficult to cover large areas. Okay, so suppose there is a flood, so I can go to one place at one time and get my interviews, especially journalists. You have seen that whenever such thing happens, then the journalists are there, they're taking personal interviews, okay, and giving you updates upon the situation there. The second is the indirect interview. Now, what happens in the indirect interview is that suppose that there is an accident, there has been a severe accident, and then what happens is we will ask people nearby, who are staying nearby, whether they know about the accident or what they heard. So that is the indirect interview. Again, the disadvantage here is it is very difficult to cover large areas. The third is the telephonic. It is quick, it is inexpensive, and you are able to easily access people over a larger method. But the disadvantage is that there are a large number of no responses also. Okay, suppose I'm trying to find out whether a particular brand of tea is good or not. I've launched a new brand. Then I have given samples also. And so I call up the people to whom I've given samples. Then what happens is whether or not that person responds is a big problem. If he does not or she does not respond, then I'm not able to collect the data. So even though I'm able to reach a larger crowd, but there is a chance of no response. So this is the interview method. So first method that we have studied for collection of primary data is interview method. In this, there are 3 types of method: personal interview, indirect interview, and telephonic interview. The second method we are going to talk about is the mailed questionnaire method. Okay, mailed questionnaire method. In this, we frame and organize sequential list of questions and mail to the respondent. Okay, organize sequential list of questions and mail to the respondent. That is, a lot of effort has gone into drafting those questionnaire. Okay, it is not randomly what I've thought and I've written. So first we'll think about the questions, we'll draft them properly and then mail them. Okay, wide areas it can be covered here. So I can reach anybody who is sitting here. I can reach a student in Sikkim, I can reach a student in Porbandar or even Chennai. So that is possible, but what happens is that people should respond also. Okay, so mailed questionnaire, I draft the questions and I send them to so many people and wait for the responses. Then next is the observation method. Okay, in this I may use instruments. Okay, in this I may use instruments. Like when I'm collecting information about height of students, so I make each student stand, I measure his or her height. So that is the observation method. So here it is a little tedious, it is time consuming, and a smaller area is covered. So suppose I'm taking height of 50 students, so it is going to take me around 2 periods of your school time. So after that, what happens? I'm able to cover only one set of students. Then for that, then the teacher will have to go to the next class and then the next class. So this is a problem. Then questionnaires filled and sent by enumerators. Okay. So here what happens is that when it is mixture of what? It is a mixture of questionnaire and personal interviews. Okay. So here what happens is that the questions are already framed, but the person who is going to collect that information goes up to the person from whom he has to get information. He will ask the question and then write down what the responses are. Like I remember way back when I was in college, they wanted to launch the dandruff, the shampoo for relief from dandruff. Okay, so at that time they had given those samples to us in the college, and then they had to give that sample. First you had to answer the question. So in that they had written questions. Do you get dandruff? What do you do when you get dandruff? Which shampoo do you use? And do you use shikekai or not? All those questions were there, and then they asked us the question, and then we answered those questions. Once we finished answering, then they used to give us the sample. Okay, so that is a questionnaire filled and sent by enumerators. Now, this is about primary data. Secondary data is easily available from World Bank or WHO, IMF, okay, in India, Indian Institutes, Statistical Institute, NCRT, then research publications. So all these are secondary data. Very important aspect of information is data is the scrutiny of data. So what happens when I'm collecting the data? I may make an error. It may be human error. So I want to minimize that. So for that, I should, whenever I collect data, I have to check its accuracy and consistency. Okay, and that is known as scrutiny of data. Okay, there is no set procedure that once you get the data, this is the method you have to do. But as much as possible, you incorporate many things so that you are sure that the data collected is error-free. So we talked about types of data, that is primary data and secondary data. Methods of primary data collection is interview method, mailed questionnaire method, observation method, and questionnaires filled and sent by enumerators method. Okay. Interview method may be personal interview, indirect interview, or it may be telephonic interview. Then methods of secondary data collection is international bodies, government, private, unpublished data. That can be methods of collecting secondary data. And then we are talking about scrutiny of data. So that scrutiny means that we are talking about whether the data is accurate and consistent. Mohammed, we are talking about mail questions, and questions filled and sent by enumerator is when I mail. Okay, so suppose I make a list of questions and I mail it to you. Now I have to sit in my office and wait for Mohammed to fill that questionnaire and answer and send it back to me. Okay, I even give a envelope which says it is stamped also. All you have to do is fill that form and put it in the envelope and just put it in the post box and send it to me. Now what happens there is, suppose there is a lot of rains, so you could not go to the post office to drop in the letter or drop in the data that I wanted. Okay, so you say forget it, and then you don't. So what happens is, even though the questions have reached you, I'm not able to get information from you. What happens is, when the questionnaires are filled by the enumerator and sent, is that then what I do is I appoint, say, Khushi. So I appoint Khushi and I ask Khushi, please go to Muhammad with these questions, get his information. So Khushi will come up to you, she will collect information from you, and she will fill up the form or fill up the questionnaire, and then she will mail it to me. So I have given Khushi a list of 50 students, and I've told Khushi that you have to collect the information for 50 students. She will go, she will collect the information and send me data of 50 students. So this is a better way of getting information, where the questions I have framed, but Khushi will make sure that each one of you is going to answer those questions, and then she will send that data. Okay, so that is the difference between mailed questionnaire and questionnaires filled and sent by enumerator. Now, Sanjana, secondary data is reliable provided that you take information from right sources. Okay, not WhatsApp industry, you know. You will find that information about inflation, about job opportunities, you know, somebody will put some information. So if you really want information about job opportunities, you want information about growth of jobs in India, then you should go to the government website, find out the information at gov.in, and then take that information. So then it will be authentic information. And I'm not saying private information is not good. It means that I have to make sure that it is coming from a right person. Okay. Arshdeep, the PPT is already uploaded. Avinash, there is no expert method. It will depend on your situation, what information you need. Okay. Like suppose there has been an accident and you made questions and you are asking and asking. So that time that person may not be in a position to answer. So in that case, what you do is you just take information directly. Okay, you talk to that person. You won't have time to appoint people who will go up to there and ask questions. Okay, so that time you have to do it on your own. Yes, crystal clear. Good. Yes, information about national income, GNP, Lakshita, you can get this from the government websites. Yes, Avinash, very good. Very good example. Like you were taking up a marketing assignment. So in that you went door to door and asked them questions, got this information, and then you submitted your report on it. Very good example. Yes, Khushdeep, these questions do come. Okay. So, Avinash, source depends upon our purpose for which we required it. No, source, you should always think about source as reliable source only you get. Our purpose will determine how much information I need. Okay. Like casually, when you're talking amongst friends and you're saying, which toothpaste do you use? You do it very casually, isn't it? Or somebody is telling, oh, this new toothpaste has come in. Which do you use? So that is very casually done. So that time you're just asking friends and it ends. But if I want to introduce a new product, a new toothpaste, then in that case, my gathering of data will be very important. Okay. So then I have to get the information well. Yes, Sheikh. Good. Profit and loss, etc. Right. Now, these are also some words that you may get as in MCQs is, so how do I present? I have collected the data and now need to present the data, and last stage will be the analysis of the data. So presentation, we are going to talk about presentation. So this presentation perspective is, first is chronological, which is also called as temporal, and which is also called as time series data. So in this case, chronological. So for the example purpose, I've given you the number of CA aspirants over the last 20 years. So I start plotting or I start collecting information about how many students enrolled for foundation right from 2000 onwards up to 2022. So that information is information that I collect in the chronological form. So I collect for 2000, then 2001, then 2002, and so on. It is also called as temporal or time series data. Okay. The second is geographical or spatial series data. So what happens in this is that when I'm talking about particular region, so suppose I'm talking about the WRC, so then I'm talking about number of CS students who have enrolled for foundation in Maharashtra and Goa and Gujarat. Okay, so that will give me information about the western region. So that is a geographical region I have tried to consider. Then qualitative or ordinal data, okay, geographical or spatial series of data, and qualitative or ordinal data is when I'm gathering information about nationality. So suppose I want to see how many foreign tourists visited India during Kumbh. So in that case, I want to information will be gathered about domestic visitors and international visitors, but I'm interested to know about the nationalities. So that in that case, I will collect the qualitative or ordinal data, which is information that I'll ask the people which country they belong to. Okay. Then quantitative or cardinal, that is the normal we have done in right from school days. That is the data we collect, height, weight. Okay. Mode of presentation of data. So now what has happened is we have considered what are the types of data, what is data, what are the types of data, what are the methods of collection of data, primary and of primary data, and then we are talking about secondary data, how from where we can get information. Okay. Then we are talking about presentation of data. So these are the four presentation perspective in terms of chronological, geographical, qualitative, and quantitative. Now I want to present this data in terms of how I can do it. I can do it from textual, I can do it in the tabular form, or I can do it in the diagrammatic form. Okay, so first we are going to talk about textual. Now, what does textual mean? It means that I collect the information, I just write it down. Okay, there is no presentation. I say that on day one, so many visitors from China were there. Then visitors from Ukraine were so many, and all this information I gather and I write it down. So, and then I make a report on it. So, what happens here is the simplest way in which you can put forth your data. Okay, it is very simple to understand because it's written in pure in normal English and or whichever regional language you are using, and then an exactness of data can be maintained. So usually this method is one of the first methods in which we will present the data. So textual is the simplest method. The demerits of this method is that obviously it is monotonous, it is difficult to derive significant insights, or it is difficult to compare two data. Okay, so suppose I obtain information about tourists visiting India in 2022 and then with 2018. So what happens here is because it is in the text form, I will have to compare. So maybe that time my language is just different. This time my language is also different. So comparing the information becomes very difficult. Okay. So the most commonly used, and especially for you in terms of exam, is we are using the tabular form of data. So in this, what happens is we will form a table. There will be rows and columns. We will give names to the rows and columns, and there will be a title, there will be description of what we are going to put in the chart or in the table. So these guidelines you should follow while making a table. So let's see what those are. So first is that you should allot a serial number along with a self-explanatory title. Okay. Then a table consists of a caption. Okay. Then it's a box head, start, and body. Okay. So we will see this one by one. So we will do this. Then what is the caption? Caption will be the upper part of the table, which is describing the rows and columns. Okay. Which is describing the columns and subcolumns. Then what is the box head? It will consider the whole thing. The whole upper part of the chart is your box head, where you're describing the columns, the subcolumns, and so that is going to be your box head. Then stub is the description of the rows. So stub is usually on the left hand side, and that which is going to describe all the rows of the table. And body is the information that you have. Okay, that data you're going to all put it in the body. Okay. Usually it will be like this. Okay, so this will be stub, where we are describing all the rows. This will be this whole thing. This will be your box head. Whatever is written over here, okay, this is your caption. Okay, and then this information. This is your body. Okay. The third important point is the table should be well balanced in length and breadth. Okay. The data should be arranged in a table such that comparison between different figures is possible without much labor. Okay. So row totals, column totals, units of measurement should be shown. Okay. Then data should be arranged intelligently and in a well-balanced sequence, and the presentation should be appealing to the eye. So how we have written it should give me information, or I should be able to deduce information from the given table easily. Okay. I should not go around finding, okay, where is this written? Where is this information written? So that should not be happening. So how I name the rows, name the columns is also very important. And another important thing is I should mention unit of measurement when it is involved. Okay, so if I'm talking about marathon running versus running athletics, suppose maybe it is a relay. Okay, 400 meters relay. So in the 400 meter relay, what will happen is that I'm each of the athlete is running for 400 meters. Okay, but when I'm talking about comparing it with when I'm talking about marathon runners, so those will be in kilometers. So I should mention that properly. Okay, what is the unit of measurement? So, and to give more clarity, you should also have footnotes. You should also have footnotes. Okay, so This will have a serial number. It will have a title. It will have a title. And then I will also have footnotes. Okay. Okay, so this is an example from the study material. So see, this is the serial number. Then this is the title. Now this is your box head. This is your stud. Then these are your captions. Okay, and this is your footnote. Okay. So caption is the upper part of the table describing the columns and subcolumns, if any. Then the box head is the entire upper part of the table, which includes column and subcolumn numbers, unit of measurement, along with the caption. Okay. Third is stub, is the left part of the table providing the description of the rows. And fourth is body, is the main part of the table that contains the numerical figures. Okay. So hope you've understood this. Okay, in this case, all this information will be the body. Now we talked about textual form of presentation of data. So now we are talking about the tabular form of presentation of data. So what will be the advantage? Obviously, it is easier to compare and draw conclusion. It is easier for the eyes also. So visual appeal is there. Okay. Complicated data can be put in a table form for ease of understanding. And it is the precursor to diagrammatic representation of data. So first we are talking about the tabular textual form of data. Now we are talking about tabular presentation of data. Once I have the tabular form of presentation of data, I can use this to form the pictorial or the diagrammatic. So I can, using this information, I can draw a pie chart, I can draw a histogram. Okay. Statistical analysis in most cases is impossible without the tabular representation. Okay, most of it times. Then mode of presentation of data and the diagrammatic. So textual, tabular, and now we are talking about the diagrammatic. Now, it is usually used for time series. Okay, so line diagram. So we are talking about different diagrammatic representation of data. So first we are going to talk about is the line diagram. Okay, line diagram. So usually used for time series. Now suppose we are comparing runs. So in this case we are comparing runs scored by Mumbai Indians versus RCB. Okay. So when I'm doing that, I'm taking information for say 2016, 2017, 2018, 2019. So this is information about runs scored by the two teams in the IPL. So here what happens is that dependent and independent variable are plotted on a graph and the points are sequentially connected to show the trend or lack of the trend. So here what is happening is I'm writing the years on to my x-axis. So I hope you know that this is my x-axis and this is my y-axis. So dependent I'm showing on the y-axis and independent I'm showing on the x-axis. So in this case 2016, 17, 18 are independent variables and run scored is a variable that I show on the y-axis because that is going to change, vary, or that is going to change. Okay. Then multiple line charts may be used on the same graph to represent separate but related data set. Okay, so these are multiple line charts because this information is for Mumbai Indians. That is one line chart, and this is information for RCB. So this is an example of multi-line charts, multiple line charts. So the first form of diagrammatic representation that we are talking about is the line diagram. and you can have multiple line diagrams. And in this, you can even have multiple axis charts. Okay, in multiple axis chart, what happens is, I'll just show it over here. So in multiple axis chart is that I have an x-axis here, and then I will have different y-axis. Okay, so what will happen is I may have this. I may have this. Okay, so this is what different y-axis are there, so that I can come. I have different using it becomes simple that in one graph I'm able to show. Y-axis having different, so that what will happen, I can have different units of measurement also, so that can be done here. Okay, the second we are going to talk about diagrammatic is the bar diagrams. So bar diagrams are of two types. One is a horizontal and the other is vertical. Okay, bar maybe horizontal or it may be vertical. Horizontal, we usually use it when we are talking about qualitative. Okay, qualitative features or qualitative data, that is when we use it. Vertical is when you want to present data in a proper quantitative data. This is qualitative data. Okay. How do I represent in the bar diagram is in the bar diagram, the columns, these are same length, same width. These are same width or equal width. Okay, the same width or equal width. Okay, the length may be different. Okay, the width remains the same, the length will be different. They may be grouped, they may be combined, or they may be slit depending on the data that you have. The third type of diagrammatic representation of data. So first type was a line diagram, second time was horizontal the bar diagram, and the third is now we're talking about the pie diagram. So this is one of very used, especially in advertising. You know, these are used. Suppose you're finding out information about income of a person. So I'm talking about income. So I come to know that he is a salaried person, that is, he is employed in some company and he's getting salary from here. Then he has made some investments which are giving him interest. Then suppose he also has a house which he has given on rent. So he's getting rental income also. So all this information is gathered, and then when I represent this on a pie chart, so I will get this. How to make the pie chart? When we will do the sum, we will understand. Okay. So here what happens is we are going to consider the total, in this example for total income, we compare it with 360 degrees. Okay. Because as you know, in a circle, if I start from here and I come back here, I have traveled 360 degrees. Okay, I have traveled 360 degrees. So I compare my income with 360 degree, and then I'm able to find out. So looking at this graph, I come to know that 50% of his salary is from where? It is from 50% of his income is from salary. Okay, so this is useful here. And if I make it for costs, okay, well, how much do I spend at home? How much do I spend in hoteling or shopping. So all this information, if I present it in a pie chart, I can easily identify the areas where I should cut down my expenses. Okay, so that can also be done using pie charts. The common mistake is that suppose I look at this diagram. Okay, this chart, what is it showing? It is showing the average height of people in Japan, India, UK, and USA. Okay, so what happens here is, if I see like this, only if I see the diagram, what do I see? It's an increasing graph. Okay, it's an increasing graph. But is it what is important? It is not that heights are increasing. It is just showing that if I pay attention over here, so it is comparing the height of student, maybe a student from Japan to India to UK to USA. Okay, so I cannot just jump to conclusion, and just because I have a graph and I have collected data and I've scrutinized the data and everything is okay, I just can't jump to conclusion. I have to make sure that I'm choosing the right x-axis and y-axis. So this is this, as you can see, is looking like increasing, but what happens is, if I write USA, UK, India, and Japan, if I just reverse the order in which the countries are written, you will see that it represents like the graph is decreasing. So that is not the case. Okay, so you have to be careful about axis and the data type that we are using. So what have we done till now is textual presentation of data, tabular presentation, and diagrammatic. The types of diagrams may be line diagram, bar diagram, graph diagram. Okay, so these are some of the types of presentation of data we have done. Okay, so before we go into the next, the calculation aspect, so I hope you've understood till now. No, Rohan, theory. This was the theory part. Now we'll be beginning with the sums. Okay. Yes, Lakshita, the person is not in a position to give answers directly, so you will ask indirectly. Okay, so suppose a person who is injured and he is in ICU, so you can't go and ask him directly. Okay, so in that case, so you can ask people who are around, who helped him, who helped take that person to the hospital. Okay. The self-explanatory title means that I should write the title in such a way that a person who is reading the title will know what is the information that you are trying to put over there. Okay. If I just say height, if I just put the title height, what will I understand? Nothing. If I say height of students in Kendriya Vidyalaya, then what will it will be self-explanatory. Okay. So then I know we are talking about heights of students. Okay. We are not talking about heights of older people, or we are not talking of heights of infants. Okay, we are talking about heights of students. Yes, Ruchi, they are used in marketing to show market trends, pie charts. Yes, Arshdeep, the statistics has importance in stock market. Monotonous means every time you want to know how Reliance is doing, you have to take out the report, read the report. Then instead of that, if I go to the there are so many business channels on the TV, and if I put up the one channel on, I can see quickly the graph. So it will show me the graph. What was the stock price of Reliance at 9:30 in the morning, and what it was at 3:30 when the markets closed. So I can easily understand whether it's an upward trend, downward trend, or it's been stable. Okay, so it's no longer monotonous. You really want to work on it. Again, because when I'm writing the report, so much of objectivity may also come into play. So how I view and how you view. So here what happens is, easily you looking at the graph, you'll be able to find it. Yes, Saima, when we do the example, you understand pie chart. Yes, we are going to talk about logarithmic and ratio charts also. Okay. Yes, Simon. Okay. When we do the sum, you'll be able to understand. Okay. So now we take a break for 5 minutes and then we come back and we will begin with the sums. Okay. Welcome back. Okay, so now we are going to talk about the actual sums. Okay, so we are talking about frequency distribution. So what is it? It means counting across variables and attributes. So whatever information is there, I'm going to take this information and put it in a form which is easier for me or for any reader of that report to understand. Okay. When frequencies are counted and represented in a tabular format, it is called as frequency distribution. Now, when tabulation is done for discrete variables, you may have grouped, ungrouped, discrete, or what is known as simple frequency distribution. When tabulation is done for continuous variable, you call it as group frequency distribution. So, when you are reading a book on statistics and you find it's a simple frequency distribution, that means what? That the variable that you are going to talk about is a discrete variable. Group frequency distribution is when you're talking about the continuous variable. Okay. Now what happens is, following are the record of babies born in a nursing home in Bangalore during a week. So B represents boy and G represents girl. So what happens in a nursing home? What they are doing is they're just recording. When the boy is born, they will write a B. When the girl is born, they will write a G. Now when I see this, okay, when I see this is not giving me any information as such. I'm not able to make out how many boys are born, how many girls are born. So what I do, I prepare a chart. Okay, what I do, I prepare a chart, and here I say category, or I may write down gender. Okay, and here I will say number of births. Number of births. First, here I am writing boys are represented by B and girl, which is represented by G. I will start counting how many boys are there. First, I'll count the boys. Okay. So I go column wise. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. So 16. Now I will try to count the number of girls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So how many girls are born? 14. And what is the total? 30. So that out of the 30 births that took place in the nursing home, 16 were boys and 14 were girls. Okay, this is the meaning. Now we will prepare the frequency distribution which you will be using now henceforth. So how do I make the frequency distribution? Is first I find the largest and the smallest observation. Okay, I find the largest and the smallest observation. There will be data given to you. So find out which is the largest number, which is the smallest number, and you will get range which is equal to largest minus smallest. Okay, so finding the difference will give me range. Also, I know that range will be equal to number of class intervals into class length. Okay, so if class length is given to you in the question, then you will, using this range, you will find out the number of classes that you need, class intervals that you need to make. Okay, then present the class and class interval in the table which is known as frequency distribution table. Frequency distribution table, I'm going to use that. And in that, I'm going to write down the class and class interval. Then I will apply the tally mark, like what we did just now. So similar to that we are going to do, but I will be showing you another way to do it. So tally marks. So in tally marks, what happens is I will mark 1, 2, 3, 4. When I'm counting, when I have counted 4, I will put a line across. Then 6, 7, 8, 9. Then for 10, I will put a club. So just looking at these bundles, you know, it is as if sticks are laid. So you will just make those bundles of 5 each. Suppose I have only 12. So then what will happen? This is 5, this is 5, and this. So just looking at this also, I can make out 5 plus 5 plus 2, which is equal to 12. Okay. So those bundles are made. Those are known as tally marks. Count the tally marks and present these numbers in the next column known as frequency column. And finally, check whether the total, this is important, that the total of all these class frequencies tallies with total number of observations. So class frequency summation should be equal to total frequency. Okay, correct. So now let us do the sum. So we are going to solve example 14.5 on page 14.15 to understand terms like class limit, class boundary, midpoint, class width, cumulative frequency, frequency density of a class interval, relative frequency, and percentage frequency of a class interval. So all these terms that are new to you, you will be able to understand once we start with trying to solve the problem. So what is frequency distribution? It means counting across variables and attributes and presenting it in the tabular form is frequency distribution. Okay. A review of first 30 pages of a statistics book reveals the following printing mistakes. Okay. So from here I can see what on page number 1 there was no mistake. In page number 2 there were 4 mistakes. Page number 3 there are 2 mistakes. So if I'm taking 30 books of 30 pages of a book on statistics and I count out how many printing mistakes are there and I correct this information. Okay. So what this means is, suppose this is mistakes on page 1. And these are number of mistakes on page 3. This will be number of mistakes on page 29. Okay. So this is the way I have collected that information. Now I want to make a frequency distribution out of it. Okay. So this is a chart I will prepare. In the first column, I'm writing printing mistakes. In the second column, I'm writing tally marks. And the third is frequency. That is the number of pages these many mistakes are there. So first we'll give you the number of pages in which no mistake is there. Next in this will give you number of pages having one mistakes only, and so on and so forth. Okay. So from this, what did I realize? The maximum mistakes is 6. Minimum mistakes is 0. Okay. This I have seen. Now I have to just put them. Okay. Now I will first count 0. Okay. How many 0? How many pages are there in which there is 0 mistakes? So this is 1. So I'll put the line here 1. Then first, second, third, this is 2. So I'll put another line 2. Then third, 3. Then 4. So 4. Okay. So that means how many pages are there? 4, and this is one more, 5. Okay. 1, 2, 3, 4, 5. So I will put it across. So means what? I have seen how many pages are there with 0 printing errors. Okay. Now let us see first number of pages having 1 printing error. So this is 1, 2, 3, 4, and 5. Okay, so 1, 2, 3, 4, and 5. Then let us go to 2. 1, 2, 3, 4, 5, 6. So this will be 1, 2, 3, 4, 5, and then 6. I will again form the new bundle. Okay. And let me see 3. How many are there? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, and then 5 and 6. Then how many 4 errors? 1, 2, 3, and 4. There are 4 pages in which there are 4 errors. Then 5. How many pages with 5? 1, 2. 1 and 2. And how many with 1 error? How many pages with 6 errors? There is only 1 page having 1 and 2. 1 and 2. So there are 1 and 2. 5 is also 1 and 2. Okay, let me just put them. Let us see. I'll first put and let us see whether they add up to 30 because there are 30 pages. So the number of errors cannot be more than 30. So this is 5, 5, 6, 7, 4, 2, 2. How much is this? 10, 10, 20, 20, 11. Okay. So I got one mistake more. Have I written 5, 5, 6, 7, 4, 2, 2. Zero is 1, 2, 3, 4. 1, 2, 3, and 4. So this is 5. Okay. So 0 is 5. 1, 2, 3, 4, 5. Let me see 1. How many pages are there? 1, 2, 3, 4, and 5. There are 5 pages are there. How many did I use? 5. Okay. Then 2. Let us see 2. 1, 2, 3, 4, 5, 6. There are 6 pages. 6 pages. With 3 errors. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so for this 3 you have 6. Okay, for 3 you have 6. So this becomes 6, 10, 10, and 10. So 30 is correct. Okay, so the total of this is 30. Now we are going to talk about 14.6, some example we want to solve. And here you will be able to form the whole of the distribution. Yes, Bhumika, thank you. Thank you. Page number, Chahal, I think it will be 14.15 or something like that, but you'll have to see. Yes, Anika, very good. Thank you for pointing it out. No, but Abhinav, because there were very few, na, so I did not cut. You have to cut here. See, I've cut later on also. Yes, Sanjana. Yes, Madan. Yes, Bihu. Okay, 13.16 she's saying. Okay. Now let us take this example. So what they have done is they have given you information about students, 36 students of St. Xavier College. The weights of these students has been given to you. And they are asking you to construct a frequency distribution while taking class length as 5. Okay. So I need to construct a frequency table for the weights of 36 students of St. Xavier's College. Okay. The first step is finding the range. What is maximum weight minus minimum weight? Range is how much? What is the maximum? 73 minus minimum weight is how much? 45. Minus 45. 44 is also there. -44 minus 73 minus 44. That is how much? 73 minus 44. 29. Okay. So I found the, what is this? This is the range. Now what they are saying is number of class intervals. So number of class intervals into class length. They have already given me class length as 5 into 5 is equal to range. Range I found out how much? Range is 29. So number of class intervals will be 29 upon 5, which is nearly equal to 6. Okay. Because this is 29 upon 5 is 5 point something, 5.8. So that is nearly equal to 6. So that how many class intervals will you have? 6 class intervals. And of what size? They are size of 5. Class length is 5. Okay. So clear up till now? Now. Now, what is the smallest number here? Smallest number is 44. Class length is 5. So, what will be the class interval? 44 to 48. Okay, first class interval. Will be 44 to 48. Now, we are going to talk about what is class limit. Corresponding to a class interval, the class limits is defined as the minimum value and maximum value of the class interval. Okay, because my minimum value is 44, the first class interval is 41 to 44 to 48. So this 44 will be the lower class limit and this 48 will be the upper class limit of the particular class 44 to 48. It is known as lower class limit. This is known as lower class limit. This is known as upper class limit. Then a very important concept is that of class boundary. Now, class boundaries may be defined as the actual class limit of a class interval. So, it is the actual class limit. For overlapping classifications, like we have 10 to 20, then it is 20 to 30, 30 to 40, and so on. These class limits, class boundaries in this case coincide with class limit. So for continuous, class limit is equal to class boundaries. Okay. This is usually done for continuous variable. However, for non-overlapping or mutually inclusive class interval, overlapping or mutually inclusive class interval, we have to include both the class limits. So what happens in this case, for example, I've got 0 to 9, or here in the current example, 44 to 48, okay, and so on. So what happens 49 to 50, 54. So what happens is, because there is this gap, so can you see this is ending at 48 and this is starting at 49. There is this gap. So I want to reduce this gap. So what I'll do is I find out the difference. What is the difference? D is 49 minus 48, which is 49 minus 48, which is equal to 1. Okay, so I found out D. Now what will be the lower class limit? Lower class limit of the first is 44. Lower class limit is equal to 44. Upper class limit is equal to 48. Now let me find lower class boundary. It will be lower class limit, that is 44, minus 1 upon 2. Because what is 1? Because there is a difference of only 1. So 1 upon 2. And upper class boundary will be for this class interval, it will be 49, 48 plus 0.5 upon 2. Okay. So D is the difference between the lower class limit and of the next class interval and the upper class limit of the given class. Now midpoint. So what do I do? Midpoint will be equal to lower class limit plus upper class limit upon 2. So what I have here is 44 to 48 is my class interval. When I'm talking in terms of boundaries, what will happen? It will be 43.5 plus 2, 48.5. Okay. So that I have now got the boundaries. Okay. So here 44 minus half is equal to 44.5. Okay. That is what we have taken here. So these are the class intervals. These are the class boundaries. Now we are talking about midpoint is lower class limit plus upper class limit upon 2. Lower class limit is 44. Upper class limit is 48 upon 2. So for this class interval, what will be the midpoint? 44 plus 48 divided by 2. 46. Okay, so this is equal to 46. And similar lower class boundary plus upper class boundary is 48.5 plus 43.5 upon 2. So how much is this? Which is equal to 46. Okay, so you found out how I can find midpoint by two methods, by either using LCL, that is lower class limit and upper class limit, or using lower class boundary and upper class boundary. Weight or size of a class interval. Okay. It is defined as the difference between the upper class boundary and the lower class boundary of that class interval. Whichever class interval I am taking, when I find out the difference, so width is equal to LCB or rather UCB minus LCB. Okay. So for the distribution of weights of BPA students, the class length or class width is how much? will be equal to 5. That they've already given in this sum. Okay, now let us form the frequency table. Let us form the frequency table. Can you do that? Can you make this frequency table on your own? I'm giving you 1 minute to try and then I will show it to you. So first class interval is 44 to 48, then 49 to 54, 53. So 54 to 58, 59 to 63, 64 to 68, 69 to 73. Okay. Now I put in the tally marks and I will get the frequency or number of students. Now I will start from here. In this case, we are going to do one by one. Okay. So here, now the number is 70. So I take 70. Where will it fall? It will fall in 69 to 73. I will write 1. The stick tally mark here. Then 59 will be here. 70 will be here. 65 will be here. 73 will be here. Then 68 will be here, 70 and 70. So 4 and then 5. Now we have 49. 49 will be here. 45 will be here. 57 will be here. 65 will be here. 61 is here, 55 is here, 44 is here, 62 is here, 61 is here, 65 is here, 69 is here, 64 is here, 47, 68, 47, 68, 47, 68, 73, 73, 57, 56, 57, 56, 64, 67, 64, 67. Then 50, 68, 50 and 68, 50, 68, 49, 60, 49 and 60, 49 and 60, 59, 55, 59, 55, 63 and 50, 63 and 50. So total number of students whose weight lies between 44 to 48 is 3. There are 3 students whose weight lies between 44 to 48. 4 students whose weight lie between 49 to 53. 5 students with 54 to 58. This is 5, 6, 7. 7. This is 9 and this is 8. Now let me check the total. 3 plus 4 plus 5 plus 7 plus 9 plus 8. That is 36. Okay, so Yeah, we are able to form the tally chart and we are able to do this. Yes, Akaldeep, very good information that you've given. Arshdeep, we took the range because using the range, I was able to know how many class intervals I need to make because they have given me that the class length is 5. That I already know. But I need to know how many class intervals should I make. So for that, I take the range divided by the class length and I will get the number of class intervals. Okay. Arshdeep, I hope you've understood now. No, Richi, you can count it as 5. Okay. So in the class interval 44 to 48, which are the weights? Which weights will I see? Pay attention, Ruchi. Which weights will come into this class interval? 44. Any person whose weight is 44, 45, 46, 47, and 48. How many are there? 1, 2, 3, 4, 5. So class length is 5. Okay, these are the 5 weights I will consider. Any person whose weight lies within these 5, that person's weight I'm going to put in that class interval. Okay. Okay, Zeba. See, you've understood up till here that range I found out to be 29. Now class interval was given to me as 5. Now in the theory you have read that class length is 5. I now need to know number of class intervals I need to form. So 29 is my range, that is the total numbers that are possible upon 5, which is nearly equal to 6. Okay, so I need to form 6 class intervals. Now where do I start? I start from the smallest number. What is the smallest number? 44. Okay, smallest number is 44. Where is it? This is my smallest number and this is my largest number, but I begin with the smallest number. So my smallest number is 44. So the class interval, I need to form the class interval. I took the smallest number. Zeba, I hope you're paying attention. So smallest number, and from that I need to form a class interval with class length equal to 5. So from 44 I formed, so 44, 45, 46, 47, 48. So this becomes the first class interval. Once this is over, I go to the next class interval. So up to 48, the weights I have considered, I go next to 49. So 49, then class length is 5, so 53. And where do I stop? Because my largest number is 73, so I am able to find it. Okay. Yes, Ruchi, class length and class width are the same. Okay, you want class boundary. See, what happens when suppose I have class interval 20 to 30 and 30 to 40. It is continuous. Can you see 20 to 30 and 30 to 40? No number is missing. But when I have class intervals such as 0 to 9, then 10 to 19, Okay, what happens when I have a figure 9.5? Should I put it in this class interval or should I put it in this class interval? So to avoid all this, we define what is called as class boundaries. These are the actual class limits. So these are the actual class limits of a class interval. Okay. So what happens here is, how do I find out? What is the difference between this? What is the difference? This is 9 and this is 10. So what is the difference? 10 minus 9, which is equal to how much? 1. Okay. So d by 2. So what happens is, once I take the lower class limit and subtract d by 2 from it, I will get what? I will get the lower class boundary. So that will become the lower class boundary. So 44 minus 1 upon 2, which is equal to 44 minus 0.5, which is equal to 43.5. For this class interval, we are talking about the class interval 44 to 48. Now, what is this is your lower class boundary. So, upper class boundary, what is the class 48? So, 48 plus 1/2 is 48 plus d by 2. D is 1, difference is 1, upon 2 is 0.5, so 0.5. So, which is equal to 48.5. I do this for every class interval. What will happen is, I will show you over here. So, I am now able to write this as 43.5 to 48.5, then 48.5 to 53, 48 to 53.5, then 53.5 to 58.5, and so on. So how now you can see that all numbers are covered. So 43.5 to 48.5, and again the next class interval has the lower class boundary as 48.5. Okay, so that what are class boundaries? They are defined as the actual class limit of a class interval. Okay. Yes, we can do that. So maybe we'll take as much as you can. We can. No, Ashdeep, 73 is the last. That is not. This is the largest number in my data for this class interval. When I'm considering this class interval, this is my lower class limit and this is my upper class limit for the class interval. Okay, I have to find it for the class interval. Lower class limit and upper class limit. This now becomes 43.5 to 48.5, where this is the lower class boundary and this is the upper class boundary. Okay, this is now written as this. Okay. Okay, so we have now found this 3, 4, 5, 7, 9, 8. 44 to 48, 49 to 54, 50, 53, 53, 54 to 58, 59 to 63, 63 to 64, 53, 64 to 68, and 69 to 73, okay, which will have frequency of 3, 4, 5, 7, 9, 8, which is equal to 36, 36. Okay, I can write it this way, or I can write it as, when I use the class boundaries, 43.5 to 48.5, 48.5 to 53.5, 54.5, 53.5 to 53.5 to 58.5, 58.5 to 63.5, 63.5 to 68.5, 68.5 to 73.5. Okay, and the frequency is 3, 4, 5, 9, 7, 8. Okay, 7, 9, 8. 7, 9, 8, which is equal to 37. So when I'm writing using class limits, and when I'm writing using class boundaries, okay, this will be the way you have to write it. Now, once we have prepared the table, we would like to show it in terms of diagrammatic or graphical representation of the frequency distribution. So in this case, we can talk about histograms, we can talk about pie charts, and we can talk about line diagrams also. Then you have cumulative frequency graphs or glyphs. And so we are first going to talk about histogram. So histogram is a very simple way in which you can put in your information in a graphical form. It will give you an idea of the frequency curve of the variable. So here what happens is we make columns of equal weights and then we represent it. Okay. So here we are able to compare across class intervals and the largest frequency bar that you have, that is going to give me information about the mode of the class. Okay. So I use this here. So I will have this axis and this axis. So on this axis, I am writing 43.5, 48.5, 54, 53.5, 58.5, and so on. Okay. So here what will happen is, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 3, 5, 7, 9, and 10. Okay. Now, what I'm going to do, I'm going to start from here. What is the frequency for this class interval? It is 3. Okay. So, I will take up to 3 and I'm going to draw till here. Okay. From 43.5 up to 48.5. What happens at 48.5 to 53.5? The frequency is 4. So here, from here, I will take the line up to here because this is 4. Then 53.5. What is the situation at 5? So from here, I take it up to 5. So this again is attached to next. Now after 7, 5, it is 7. So 4, 5, 6. Then 63.5, 68.5. 63.5, it is 9. Like this. Okay. Then next will be like this. And after that, it will be 8. So it will be like this. So that is the histogram of the data that of the frequency distribution that you had. Now what happens here is, if I draw a dotted line from here, this end, change the color. From this end, this is what? This is the highest column. In the highest column, I draw a dotted line from here to here, and from here to here. So from here to here and here to here, what I get here, this point is my mode, okay, which we are going to learn in the next chapters. But using a histogram, I can find the mode of the given distribution. Okay. So here you can see it. So we started with 43.5, 43.5, 48.5, and we have gone up to 73.5. So we have written the lower class boundaries on the x-axis. On the y-axis, we are writing the frequencies. So number of students. So 1, 2, 3, 4, up to 10 we have written. Okay. So how many students are there whose weight lies between 43.5 and 48.5? There are 3 students. Okay. So there are 3 students. So this is the 3 students. Okay. Similarly here, how many number of students are there whose weight lies between 63.5 to 68.5? I've drawn over here. And when I try to connect these of the highest, okay, you have to, not any random, only the highest or the longest, rather, the longest bar that you have, you are going to take that and you're going to take the points of the earlier and the next column, and then you find. Okay, so here is this point, here is this point, here is this point. So these 2 points are very critical, and then this point. Okay, so using this you can find out the mode. And when I connect the midpoints of those bars, and then I am able to draw a frequency polygon. Okay. So I take the midpoints and write the number of students. Okay, and I get this. So my first interval is 44 to 48. So what will be the midpoint? 44 plus 48 divided by 2. So this is equal to 46. What if I use class interval, class boundaries? This is class limit. Now if I use class boundaries, so what is the class boundary of the first class? 43.5 plus 48.5 upon 2. 48 plus 43 is 11, which is equal to 4 and 4, 8 and 9. 92 upon 2, which is equal to 46. Okay. So this will give me the midpoint. So this midpoints, where did I get them? So 48, then 51, then 56, and so on. And I'm writing the frequency here. So I can draw the frequency polygon. I'll draw it over here. One, two, three, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 46, then 51, then 56, and so on. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So for 46, this is 1. Okay. For 46, it is 3. Then for 51, it is 4. 50, 51, 56, it is 5. 61, it is 7. 66, it is 9. 66, it is 9. And 71, it is 8. Okay, so what will happen over here is, from the x-axis, I try to join these points and then bring it back to the x-axis, and this is your frequency polygon. Okay. So frequency polygon, you are able to make it. The last point we are going to discuss today is this. Okay, so I will be taking up this chapter in the next lecture also, so that because this is a lengthy chapter and I would like to take up the initials very well, so that using this example of 36 students of Xavier's College, we will build up everything. So you to be clearly understanding what this whole chapter is about. Okay. And then we will be doing theory questions also tomorrow, and I think section B of the exercise. So sometimes when you're plotting, like we plotted just now, if the plotting is like this, then you say it is a class boundary with this type of shape. This is the bell shape. Then this is the U shape. Okay. Then this is the J shape, and this is the freeform shape here that we have. Okay. So this is the most commonly seen diagram or frequency curve that you have. Okay. This is the most common one. Okay, then tomorrow we will be doing the cumulative frequency. Okay, we will be calculating the less than and the more than cumulative frequency. Then we will be plotting it on a graph, that is less than and more than. Then we will be talking about frequency density, relative frequency, and percentage frequency. We will be talking about then these are the questions we will be doing. Okay. And then after that, we will be taking up some theory questions also. And then we will be seeing what else we can do with the other chapter also. Okay. So thank you all for your patient hearing. Have a great day ahead. Thank you.